Hello, everyone. My name is Andrew Blumen. I am Platform Security Team Lead at IG Group. And today, I'm going to be walking you through our presentation on how we have built highly resilient architecture in the regulated financial environments. Today, I'm going to be focusing on secrets management, namely HashiCorp Vault. So, in terms of our agenda today, I'm going to walk you through kind of the three core topics, which is going to be the challenge, the solution, the value to IG. And then I'm also going to talk a little bit about Vault and Nomad, how we've integrated Nomad with our Vault environment. So, a little bit about me. I am Platform Security Team Lead. I've been working with HashiCorp products for about 5 years now. Self-taught, but went on to do some of the certifications. My main specialty is in Terraform and Vault. So let's talk about the fundamental challenge that we were facing. And this was secrets in code, and they were scattered throughout our code base. This wasn't just a technical problem. It was a business risk that threatened our operational resilience and also threatened our regulatory compliance. So why is this such an issue for us in financial services? So in terms of the perspective we can put this into, GitHub found 39 million secrets that were leaked in 2024 alone. IBM calculates that the average cost to a business per incident involving compromised credentials is about $4.88 million per incident. That's a 10% increase from the previous year, according to IBM's cost of data breach report. And I didn't just put that in there because HashiCorp is now IBM company. In financial services, these numbers aren't just statistics. They represent existential threats to our business. Speaking of the regulatory impacts, DORA is one of the biggest changes that we've seen recently. For those who don't know, it's the Digital Operations Resilience Act. This is a significant change to financial services. And more importantly, this isn't optional guidance. It's mandatory regulation that requires us to do the following things: implement secure coding practices throughout the entire software development lifecycle, adopt the principle of least privilege for all of our systems, maintain strict separation between development and production environments, and establish frameworks to identify, detect, and respond to and recover from security incidents. Some of the guidance that we have been asked to align to and follow, which is nothing new, but just for a refresher, the National Cybersecurity Center offers plenty of guidance on this. ISO 27001 is an excellent framework to use, and also the NIST cybersecurity framework. So let's talk about the culture of insecurity that we had at IG. We identified three critical gaps in our organization. First of all, lack of developer awareness on secrets. Clear training and guidance to developers on how best to store secrets just wasn't in place. And this was causing secret sprawl. One of the things that we have talked about and that we've seen from other organizations is to design an engineering code of practice, which actually implies that developers have to use the secrets management tooling in order to avoid secret sprawl. The second aspect we found was a lack of secrets detection tooling. So we saw earlier from HCP Vault Radar is an excellent example of that. Even when a company adopts a secrets management solution such as Vault, appropriate detection tools are still needed to identify new secrets which still may be committed to the code base. The final aspect was no enforcement on committing secrets. Implementing preventative controls will be the most effective way in reducing secrets in code. This requires policy enforcement in the software development lifecycle to block code commits when secrets are detected. So from our experience, we had this concept of secrets hiding in plain sight. And what this often is organizations try to build deterministic architecture where the goal is to achieve stability and resilience. But what that can often lead to is inflexible architecture. Hard-coded names, values, and more important, secrets can actually cause a counterproductive effect which hampers security. Secrets stored in plain text, both in applications and in source control, can present a security risk if compromised. If those secrets cannot be easily rotated, this presents attackers with an opportunity for persistence within an organization's network. The self-service challenge is something that is sometimes directly at odds with the developer flexibility and security. Where do you draw the line? One of the things that we found is when self-service becomes a problem is when there's an absence of the existing solution. So if you don't have something like Vault, this can lead to secret sprawl. Without this predefined solution, developers will find a method, even if suboptimal, to deliver their work stream. And this is the beginning of secret sprawl. Access keys take time to provision. One of the things that we find is that business processes to create access tokens, service accounts are slow, and they have to go through central administrators. You have to log a ticket. This adds to developer frustration and leads to reuse of access keys. One of the things we found in some cases, a developer hasn't been able to get their new token issued for their production environment. They've reused the same one from another app. One of the apps has been rotated, and it's caused impact to the other application. The final one is going to be drift between the staging and production environments. Varying access policies between environments can lead to developers to get frustrated. One of the things that we've seen is our production environment has a lot stricter controls than our staging environment, and so developers find it difficult to actually promote their code into production. So to summarize, we had a culture of insecurity driven by the absence of an existing secrets management solution. We had to overcome the regulatory controls. We had to have massive concern about the risk, and we had a lack of proper secrets detection tooling. These, combined with the operational barriers I mentioned, were actually causing a culture of insecurity. This was unsustainable, and this is especially challenging in the financial services sector. So, the solution. We decided to solve the problem with HashiCorp Vault. Let's talk about why we chose it. Before I get into the technical aspects, I want to talk about the 3 pillars of our secrets management strategy: secret storage, secret detection, and developer experience. In terms of secret storage, we wanted to have clearly defined platform for managing static credentials. And we wanted it to be one platform as well. One of the questions we were asked originally was, do we want to allow developers to choose their platforms, or should we define it? We chose to define it. We wanted to promote dynamic secrets where possible, and we wanted human and machine access defined and easily consumable. The second aspect was secrets detection. We wanted to detect secrets in code repositories. We wanted to detect newly pushed secrets in pipelines. And we also wanted to prevent secrets from being pushed, pre-commit or git hooks. The final aspect was we wanted there to be a good developer experience. That meant simple onboarding. That meant minimal code changes for developers. And it meant clear documentation on how to use the tools. What we wanted to do was build a culture of security, and the way we've actually chosen to do that is through gamification. By having a nice dashboard where developers can see where they're standing with other teams can really help to encourage developers to be better at managing their secrets. So why did we choose HCP Vault? Well, HCP Vault delivered 3 critical capabilities. Number 1, it was easy to use. The HCP platform is really easy to deploy Vault cluster. It's cloud deployable. It's really easy to connect Vault to an AWS account using a transit gateway. And finally, it's a managed service. It means that our technical debt was significantly reduced from running it ourselves, and that means upgrades and any kind of issues can be resolved by the HashiCorp team themselves. So let's talk about the Vault adoption at ING. We had a three-phased approach. The first phase was a proof of value. We needed to know which was the best platform in the market. We looked at Vault and we looked at CyberArk's Conjur product for about 5 minutes, and then we went back to Vault. We realized that Vault was the premier secrets management tool for a reason. It is the best. We then ran an open source project for approximately 18 months to validate our approach. When we discussed this with HashiCorp, they said, look, open source is great, but it is a project. You know, they want you to buy the enterprise one. As it was mentioned earlier, it's very expensive, so they want you to pay for it. And we deployed and ran it for 18 months pretty successfully. One of the things that we also found was our adoption of the HashiCorp stack, namely Nomad and Consul, also increased. This put a higher requirement for Vault to be there, mainly because of the integration, the tightly coupled integration that Nomad and Consul need. And finally, we needed a scalable solution. The HCP Vault platform can scale with demand really easily. So our HCP Vault adoption started in February of this year, and we deployed HCP Vault in tandem with the HashiCorp professional services team. And this was one of the best moves we made, mainly because having somebody around who just understands the platform really well can accelerate the deployment. It ended up that we did all of our primary goals in the first week, and we were doing nothing but stretch goals in the second week. We found that we had to create a migration script to take secrets from the on-premise, from the open source Vault to the HCP Vault. Fortunately, we live in a world of Gen AI, and we could use Claude to help us do that. And so we made a nice script that developers could run from a GitLab pipeline to migrate all their secrets. So the question is, why is Vault right for financial services? One of the things that we found is that having that centralized visibility, that single source of truth for secrets, was paramount. It's a consistent method for developers to source secrets. The security team can monitor Vault for any suspicious activity, and that's because Vault has an excellent audit trail. One of the things we also found which was critical was policy automation. Vault has a declarative policy framework which is really easy to use. It allows for the principle of least privilege, and developers can share secrets when required. We also needed secure access methods. Vault has multiple access methods: LDAP, SAML, JWT. I promise there won't be too many more acronyms to come. Vault also enables machine-to-machine access with short-lived tokens, and it assists in building a clear secrets life cycle policy built around automation and GitOps. So just to kind of recap some of those points there from the solution aspect of what we did with Vault. Our solution choice was methodical. We chose Vault because it has enterprise capabilities, and the managed services benefits of HCP Vault were paramount. We followed a phased implementation approach and built a comprehensive strategy around storage detection and, most importantly, developer experience. Let me talk about some of the more value aspects that we got from Vault at IG. So when we talk about how does Vault make our infrastructure more resilient, first of all, there's no secrets to leak. If somebody does access our code base and download it, there's no secrets in there anymore. They've all been replaced with variables, so there's nothing to steal. But we have to ask the question, what if we are breached? If the time comes when secrets are compromised, the secrets can be rotated in the originating system and then updated in Vault centrally. No code changes are needed, but the app will require redeploy. The final aspect is just-in-time access. By using just-in-time access to securely authenticate to Vault, we can ensure that even if a token is exposed, it will expire within a short period. This limits the blast radius. I want to talk a bit now about the platform engineering aspects with Vault and how we deployed Vault using Terraform. So we optimized our deployment of cloud operations by leveraging Terraform. There's a great provider for Vault. And so we decided for all of the control plane aspects, we were going to use Terraform to manage it. There was 0 ClickOps. This means that we can administer Vault using a GitOps methodology, all built into GitLab. This allows us for version control, change control, audit logs, and it's really easy to onboard new teams. In actual fact, I've got it down to just one line of code to onboard a new team, namespace, secrets engine, roles, policies, everything gets done with one code. The accelerated delivery shows the new capabilities This accelerated the delivery, allowing us to deliver the new Vault capabilities faster via Terraform instead of using legacy manual ClickOps approach. So when we want to deliver new functionality in Vault, such as new secrets engines or PKI or other features, we can easily do this using a new module. One of the core things I talked about was the improved developer experience. So shifting left is a term which is used more and more on the topic of addressing security issues. So how have we improved the developer experience while shifting security left? Well, GitLab has a native integration which allows developers to easily access their secrets and inject them at build time into their application pipelines. By using OpenID Connect, we don't need to provide developers with any static credentials from GitLab into Vault. It's done using just-in-time access, using a short-lived credential from GitLab. So let's talk about IG's adoption of Vault. So before we had about the same number of teams in the open source version as we do now on the HCP Vault, but we're actually seeing an even higher uptick in usage, mainly because we really spent a lot of time publicizing it to our developers. So we've got 65 teams, and each team has its own namespace, dedicated secrets engine, and we've got over 2,000 secrets stored in Vault at this time. But we found over 3,000 using our secrets detection tooling, so we've still got some work to do. As we increase Vault adoption, secrets in code should decrease, means we can measure our efficacy of our Vault implementation quite well. I wanted to have a bit of a refresher on zero trust architecture. This is a really big aspect for HashiCorp. So let's just take a look at the core principles of zero trust. So never trust, always verify. No entity is trusted by default, even within the network. Trust is established based on identity and context, not network location. The principle of least privilege: grant only the required privilege for the specific task. Access should be temporary and revoked when no longer required. And finally, assume breach. Always assume the network is compromised. Design architecture to allow the rotation of secrets on a regular basis. All of the above will help reduce the blast radius and attack surface if a compromise does occur. These tenets help reduce privilege escalation, lateral movement, and adversary persistence. I want to show you how that lines up with, firstly, the 3 A's of IAM as well as Vault, so that we can see this in a more contextual manner. So we can see here, zero trust, we have never trust, always verify, and that can be mapped to the authentication layer. And we can see Vault auth methods such as SAML, JWT, OIDC. The principle of least privilege, authorization, and we can see Vault has an excellent policy framework to map to that. And finally, with assuming breach, we can map that to the accounting aspect, and we can see the Vault has an audit log. This can be fed into your SIM for detection and response capabilities. So let's talk about our secrets journey and target state. So we started off, and I imagine most organizations will start off with secrets in code. Next step is going to be to move those secrets into Vault. Although the problem with that is that the secrets are never changed. You essentially just move the secrets from source control into Vault. They still exist in Git history. There's still a problem there. So if your Git repository is breached, you still have a problem, and they're still vulnerable. So this leads on to the next section, which is going to be dynamic secrets. Secrets rotation should be the next logical step. Apps retrieve secrets from Vault in runtime, and this reduces the blast radius if they're ever compromised. The ultimate goal should be no more secrets. Just-in-time access for microservices. Vault can act as an identity provider using OIDC. And more importantly, we need to remember that we may never truly eliminate static secrets. SAS tokens from external third-party APIs will still need to be stored somewhere. Put simply, we'll always need a vault. The value to IG of adopting HCP Vault has been transformational. We're progressing really well to eliminate secrets from code. We're accelerating through automation using Terraform, and we have a clear path to low or even zero secrets. So I want to just give you a quick kind of rundown of how Vault and Nomad work together to really kind of put this all this theory into practice. So in this diagram here, we have an example workflow of how a developer might deploy a Nomad job and how that might use Vault to retrieve its secret. Now, the key aspect of this is it's using something called workload identity, which is a newer feature in Nomad, which allows us to use a short-lived access token to securely authenticate to Vault. So I'll walk you through this diagram. The developer submits the job from their Git, so GitLab, for example, to the Nomad server. That then passes it to the Nomad client, which creates an allocation using workload identity. And under the hood, this is using OIDC and a JSON Web Token. The identity is used to authenticate to HCP Vault. From there, the HCP Vault instance will return a Vault token back to the Nomad job, at which point the Nomad job can use that token to authenticate to Vault and retrieve a secret in order to access another system. This demonstrates how to take that step from just pulling secrets at build time to pulling them as part of a runtime environment. So what are the key takeaways from IG's adoption of HCP Vault and secrets management? Well, we have three critical success factors. First of all, we've strengthened security and governance. We've implemented centralized visibility, automated policy enforcement, and secure access methods that directly address the DORA requirements. We've accelerated delivery and innovation by eliminating barriers and providing self-service capabilities through GitLab and the integration with OIDC. We've increased development velocity and we've improved security. And this demonstrates that security and speed of delivery are not mutually exclusive. We've optimized our cloud operations and return on investment. Our infrastructure resilience improvements, combined with our operational efficiency gains and measurable risk reduction, deliver a really compelling ROI. The bottom line is that building resilient infrastructure is not trivial. It takes careful coordination between platform engineering, security, and the developers to ensure that the target state is reached. Today, we've touched only on the security aspect of resilience. Hopefully this stirs conversations in your organizations as to some of the other aspects which may play a factor. I very much appreciate you taking the time out of your schedule to be here. My name's Andrew Blumen. Thank you very much for listening.